Hey guys, Travis Gillespie. A very special type of linear relationship is known as direct variation. I'm going to share it with you because it comes up in your everyday life so much. It's all around us. So, direct variation is a very special linear relationship where you have a constant, I'm going to call that y equals a constant k times x. K is the constant. So, the case is don't actually think of k as an unknown variable. Think of it as a fixed number, whether it be, oh, I don't know, -2, so y equals -2 times x, or think of it as k as 6, where it's always y equals 6 times x, but it's constant. So we're going to look at some examples and, just ask yourself, hey, is it direct variation? And if so, what is that special k? I'm going to fix that 5. I don't know, the last couple videos, my 5s have been pretty sloppy, so I'm just trying to fix them up. So y equals 5x. Well, in fact, in this scenario, you can actually see it. It's pretty obvious. Hey, k in this case is 5, and it looks just like the direct variation above. It's actually in that form, and again, that constant is, or that k is 5 in this case. Well, I'm done with this problem, so I'm going to box it up. And let's actually look at another one where I say, hey, 2x plus 3y equals 0. And let's say, hey, is that one direct variation? Well, at first you'd say no way because it actually doesn't express this form. But maybe you can balance this equation, rearrange it to where it actually does express this form. Well, let's actually solve for y here. And in this case, what I'd end up doing is say, hey, let's subtract 2x from both sides. So I end up with 3y equals -2x. And now I've got to divide by 3. And then I end up with, hey, y equals that's real sloppy, so let's fix it up. Y equals -2/3 x. And yeah, actually, once you get to this point, when you solve for it, you say, yeah, it actually is in the form as the direct variation above, and the constant here is -2/3. Cool, so I'm going to box this guy up. Well, now you begin to see, yeah, you know what? Things may at first not actually seem to look like they're direct variation, but once you solve for y, set it for y, yeah, it might actually end up being direct variation. Let's try another one here where we're going to look at 4x plus y equals 8. Now, armed with the previous example, you're going to say, sure, it probably is because I'm just going to solve for y. Well, uh, cool, let's go find out. Cool, so it looks like the first thing I got to do is subtract 4x from both sides. And I end up with, hey, y ends up equaling, well, -4x plus 8. Well, let's write actually 4x plus 8. And actually that plus 8 right here becomes a problem. And the problem is this, hey, this plus 8 does not reflect this formula up top. Therefore, this is no. It's not direct variation. I can bore this guy off too. Well, in reality, if this positive 8 weren't there, it would be direct variation. But because you're adding on a constant, that positive 8, it doesn't reflect this formula, therefore it cannot be direct variation.